Hello friends, welcome to this variable frequency drive tutorial. Because this tutorial is vast, we have divided the entire topic into 10 episodes. This is part 1, where we'll see what is a VFD, where VFDs are used, what are its applications, and we'll talk a little bit about AC motors. In part 2, we'll see how to read a datasheet or a manual of a VFD. In part 3, we'll see how to wire a VFD. And in part 4, we'll see how to configure a VFD, and we'll also see a VFD in action. In part 5, we will see the internal circuits. We'll also see the schematics, electronic components such as the diodes, the igbts and capacitors. In part 6, we'll see what is electricity. We'll see 3-phase power supply, single-phase power supply, direct current and alternating current. In part 7, we'll see PWM, which is pulse width modulation. It's a technique used in VFDs. And we'll also see the 3 sections of a VFD: the rectifier section, the DC bus section and the inverter section. In part 8, we'll see how a VFD shows you the faults in your system and how you can diagnose a fault and rectify it on site. In part 9, we'll see the volts per hertz control, which is the algorithm used in VFDs to alter the speed of a motor. And finally, in part 10, we'll see how a VFD saves power and pays for itself over the years. So, why do we use a VFD? A VFD is used to control the speed of an AC induction motor. Did you know 90% of the motors installed worldwide are AC induction motors? But why do you want to control the speed? Sometimes you want to run the AC motor at slow speed and sometimes you want it to run at fast speed. We have been using VFDs in industrial cranes successfully since the last 5 years. A crane lifts heavy load and we don't want to run the motor at high speed because the load might swing and it might cause fatal injuries. They are also used in elevators, pumps. They are used in workshop machines, industrial automation facilities. Let's take the example of an industrial boiler. In industrial boilers, there is a tank full of water and this water is heated to generate steam. An AC induction motor is used to pump water inside this tank. The 3-phase power supply from the power plant is given directly to the motor and it starts running at full speed. Because the motor is running at full speed and we cannot control its speed, the water level keeps on rising. As soon as the tank is full, we have to shut down the motor. Then the water level drops. As soon as the tank is empty, we again have to start the motor. And because we cannot control the speed, we cannot maintain the level of water. If we use a VFD in between, we can control the speed of the motor depending on your requirement of steam. When there is large requirement of steam, you could run the motor at high speed, and when there is less requirement of steam, you could run the motor at slow speed and maintain the level of water in the tank. There are several manufacturers of variable frequency drives which are based all around the globe. You can find them in India, in Singapore, United States, France, Japan, Switzerland, and they manufacture VFDs for a variety of ratings of AC induction motors. AC induction motors come in ratings from 100 watts to 30 megawatts. And let's talk a little bit about AC induction motors. But why do we use AC induction motors in the industry? AC induction motors are low cost, they have less maintenance and they have a very rugged construction. There are 2 types of AC induction motors. The first one is the squirrel cage motor and the second one is the slip ring motor. Both are constructed the same way. An AC motor is made up of 3 parts. The first one is the enclosure, second one is the stator and the third one is the rotor. The stator is the stationary part and the rotor is the rotating part. In the stator, there are 3-phase windings. We will talk about 3-phase power supply in the later episode. Three-phase windings are used in the stator, and whenever we apply three-phase power to the windings, it generates a rotating magnetic field. The rotating magnetic field of the stator induces current inside the rotor windings, and the rotor windings generate their own magnetic field. Due to the magnetic field generated by the rotor, it starts following the rotating magnetic field of the stator, and the rotor of the motor starts rotating. VFDs are used to change the speed of the rotating magnetic field of the stator, which in turn controls the speed of the rotor. VFDs are not the only way to control the speed of an AC induction motor. Slip ring motors are constructed the same way, just that in their rotor windings we have connected external resistors to change the current and hence change the speed. Guys, this is the end of part 1, and if this video helped you out in any way, then don't forget to like and subscribe. And don't forget to watch part 2, where we'll be reading a programming manual of a VFD.